Okay, for part 2, it now asks us to find the angle between the two lines. To find the angle between two vector equations, we just need to look at the direction vector, because what we've got is two lines. Let me draw them. And on those lines, we know that at some point, and it doesn't matter where that point starts, we've got a vector that's going in the direction 2, 1, 3, and a vector that's going in the direction, and again, it doesn't matter where they start and how long they are, that's going 1, 4, -5. So we can pick those two lines up, and if we put them together, that's the wrong one, then that's the angle we're trying to find. So that's all to do with the direction vector. So this 1, 2, 0 and the 6, 8, 1 is absolutely irrelevant for this question. We are now just concentrating on the 2, 1, 3 and the 1, 4, -5. So I'm going to write the first vector, P, as 2, 1, 3 and Q as 1, 4, -5. And that is so that we can use this equation, that cos theta is equal to P dot Q, the dot product of the two vectors, divided by the magnitudes of the two vectors. So that's what we need to find next. We need to find the dot product and we need to find their magnitudes. Doesn't matter which order we do it. The dot product is going to be 2 times 1 plus 1 times 4 plus 3 times -5, which is -9. The magnitude of P is your 3D Pythagoras, so we're going to do 2 squared plus 1 squared plus 3 squared square rooted, which is √14, and the magnitude of Q is going to be 1 squared, which is 1, 4 squared, which is 16, and -5 squared, which is 25 square rooted, and that is 42. So now we've got everything we need. We're going to say that cos theta is equal to -9 divided by the root of 14 times the root of 42, which gives us a theta of -9 over 111.8, but it asked for the acute angle between them. So what we've actually found out is, it turns out that one of my vectors isn't going kind of in this direction, it's going in the opposite direction. So it's doing more like this, and we've found the acute angle. That line obviously carries on. That's a vector equation of a line. So that line is going to have an angle, an obtuse angle of intersection with the blue line, and an acute. We've happened to find the obtuse. The question has asked for the acute, so we just now need to take away, and you can see from the diagram there that those two angles are going to add up to 180. So to get the acute angle, we're just going to take that 118 from 180, which is 68.2.